Hello everyone, this is Yiqun Liu, and I'm recording the second demo video for my part of the project. So here we have a start API.py. This is a script that starts and Flask API. It serves a purpose so that the other team members could use this API to talk to OpenAI without modifying the code or integrate my code into their code. You could just use a post request on a REST API to do that. So here we initialize everything we need in order to talk to the OpenAI API, and then we use a conversation chain so that we could remember the previous chat history and also use that as part of our conversation. And here, this is where we initialize the server. Yeah. So let's execute this script and do that. So here I already have it running, but I can turn it around again. Okay, good. So here the server is already running, and we can talk to that API in another script. Suppose that I'm a team member in our team, and I can talk to it by using this port on localhost. So let's do that. One, I already have the prompt entered here, so show me an example of work on using MapReduce in pseudocode. Okay, let's do that. Okay, so let's check the output. We can see that we are able to generate a working, doable response, and we can also see the source of the source video that we used to generate this response. And it's also able to mark the timestamp of where this part is coming from, and we already integrated that timestamp into our video URL. And by
can actually implement all of this by using only sequential reads of this and never using random access.
And the thing is that we are dividing the video transcript into like big chunks, and so the chunks might be a minute or 100 seconds. So it's not very accurate. Like you can see that the part about pseudocode starts here, but we jump here.
And reduce, and the key is the
so we are able to successfully jump to a relevant video and the relevant part of the video. And talking about video, let's also talk about how we embedded the video. So I created this example and so that my teammate could understand how the embedding for video work, and they can. I think Ray is working on the web scraping, so he will do the web scrape part for the video using my code. Oh, sorry, not this one. Yeah, this one. So for each video, we get its transcript, and we also do manually add some overlapping, so that this works similar to TextLater and how we do TextLater and create embedding for PDF files, except it's on video transcript. And after we create that, we store it in the Chroma database. And we also append the relevant metadata. This part is crucial because By inspecting the metadata, we can tell you the source of like how we come up with the response, the source of the response. From the video ID, we can come up with the URL, and from timestamp, we can tell you like where exactly is the relevant part in the video. So these are what I have worked on this week. Thanks for listening.
So first, let's take a closer look at the scripts that enable us to script the post from the Piazza calls by using the Piazza API library. We can authenticate ourselves, specify the desired calls ID, and retrieve all the post, follow-up, and feedback associated with that calls. The script efficiently iterate over each post. Extracting essential information such as the post ID, folder, title, content, follow-up, and feedback. It then save this data to a CSV file, providing a convenient way to store and analyze the course content offline. It incorporates the TQDM library to display informative progress bars and give us real-time feedback on the fetching and the scraping process. So let's move on to the next part. It uses CSV file generated by the previous script and recreate the post follow-up and the feedback in another Piazza calls. This script starts by logging into the Piazza. Use the provided credential and specify the target calls ID. Where you want to recreate the content, it then read the CSV file row by row. Creating a new post, follow-up, and feedback based on the data retrieved from the file to ensure a smooth recreation process and handle the protection rate limiting issue. The script uses exponential backup function. This function intelligently retrieves the API request with the increasing delay if the rate limiting error occurs, guaranteeing a reliable and efficient content migration. Now let's dive into the most important part, the interactive question and answer interface that use the power of the chatbot. The script provides a user-friendly menu with 3K option post a question, answer all unanswered question automatically, and exist. When you choose to post a question, the script promote you to enter the question subject and the content, and then create a new post in the Piazza course using the provided information. When you choose to answer unanswered question automatically, the script retrieve a list of the unanswered question from the Piazza course. It then sends each question to the chatbot API, which generate an intelligent and context-based response. The script takes this response and automatically posts them as answer to the corresponding question. It will save us the time and the effort of manually addressing each query.
Hi everyone. So my name is Jaejin. So today I'm gonna introduce how to extract the data from the YouTube. The main purpose for this code is to fetch the videos related to data mining from the YouTube, extract the subtitle of those videos, and then store the subtitle along with the related information into the vector database. Here's detail to explain each step of code. So first we import. So first we have to using the YouTube transcript, the API, and launching Vectories and the Google API Clinic. And the second part, we fetch the video. So for this function, we use the YouTube API. It's right here to search the video related to given query. In this case, data mining. So it extracts the ID title for each video and it returns the video ID for title of the caller. So I set up the max result for 10, so it will be take a lot of them. And the second part is get script list function. So it used the YouTube transcript API to get the subtitle from the given the video ID. So I set up a lot of the if else try the exception. So first we have to make sure they have the subtitle. So if they don't, so we're gonna skip it. So or like if they don't have the subtitle in the video, you have to click on the like CC to create the subtitle. And so it slipped the subtitle into smaller fragment, creating 15 the overloop tree here. And for each argument to subscribe the process, it returns the process list of the subtitle for the caller. And here is we set up the data mining, so that's what we're gonna search here. And we have printed out. Let's see if we got the correct video ID. And so it's right here, this part, we have the creating the vector database and adding the documents. So for the OpenAI embedding to generate embedding vector from the document, it created instance the Chroma as vector database, specifically embedding function and the directory. For each video list, it creating a series of the document instance, each contain the segment of the subtitle and each metadata such as the video ID, title, and the time map. So let's run this code. So here, as we can see it, if there was no video subtitle, English subtitle, we will return a none. So after this part, so the document won't get anything, so they won't respond. So they will skip the video and due to the empty transcripts. So let's run this code. In the first thing right here, it's 10 of the video ID. Here is what is subtitle. Here is the time map. So this taxes. So what the 464 at the time they say something. And let's open it. So here is after we run this code, here we got the vector and the data I set up in my logo. So this is my final two, the demo video and how to extract the data from the video. Thank you, everyone.